Hello and welcome everybody. So this is today the day 4 of our Smart 25 days challenge, and today we are going to make a voting on a proposal smart contract. So this would be going to be a very simple contract in which we would try to implement how we can vote on a proposal and how different we can create a smart contract which will allow the users to vote on the proposals, and they can even propose the proposal, say they want to do something, or in a group of 5 members or 6 members, say they want to do something, or we may assume that to be a company, and in that they can propose their proposal, and then the other users can vote on that. Okay, so for that, let us now see how we can approach this problem. Okay, so first of all we need to understand the requirements. Okay, first of all we need to understand what are the requirements. Okay, so first we create a new file. Let us create a new file called voting.solve. Okay, and start by writing our comment, that is pdx MIT. Okay, then the second line, and that is pragma solidity, and then version. Okay, so let us start by writing our contract voting. Okay, so this would be our contract name. So now just write down, we'll just write down in the comments what are the key points that we need to understand in this problem, and we need to start by understanding our requirements. Okay, so today I'll be introducing two important data structures which are used in Solidity. One is called struct and other is a mapping. Okay, so what are they? We'll see. So struct is a user defined data structure. Okay, so till now we were dealing with the elementary data types. Okay, uh, like we were dealing with booleans, and we were dealing with uint 256 or uints and all, but now we'll see what is a user defined data structure. Okay, data type, and we'll also see about mappings. So first we need to ask ourselves, okay, you need to ask yourself questions like which data structure will be helpful in representing a proposal. Okay, so till now what is the thing the thing was, we were not required for a thing to have two or more attributes or properties, like till now we were only making simple smart contracts, but in a proposal, when you'll see that in a proposal you need to have the name of the proposal, then you need to define it also, and then you may need other things also, like you can specify a field called the specialities of that proposal or the benefits that it will bring, and other fields also. So basically what I am trying to say is we need two or three or more attributes regarding a proposal. Okay, so we cannot just name a proposal, like we cannot just say key string and then write the name of the proposal, that it would be not, it would not be sufficient. Okay, so what we are going to do is, first of all, let us just write the comments key, what do we need. Okay, and we'll go in that manner only, we'll begin by that. Okay, following this only. So we need what would be the data structure that would be helpful. Okay, so the data structure here, it's struct only. Okay, then the other thing is, what are the attributes that a proposal should have. So okay, in our case it would be name of the proposal, description description of the proposal, and vote count. Okay, so how many votes it has gained, and other relevant information if you want you can add. So, and then how will I? Ha. So this is now an important question. Okay. So the thing is, you have created a proposal, but now you want others also to view that proposal, what's in it. So how will I access the proposals? And I'll show you one by one how we are going to do this. Okay. And how will I keep the track of voters? Okay. Keep track of voters, like who has voted or who has not voted. Okay. So now, after this, the most important thing is the functionalities. Functionalities, which you might have guessed, like what can be the functionalities? Like the functionalities can be to add a proposal, add proposal, then to add a proposal. After that, what can be the functionality? That can be to vote on a proposal. Okay, after adding, we need to vote on a proposal, and add proposal, vote on a proposal. Then we need we also need to keep the track of we also need to uh, create a getter function or something which can actually help us in accessing the proposals. Okay, so we need to get the proposal and proposal. Okay, so we need to get it ki, what is the description of the proposal. So we need a getter function for that, and we also need we may require or we may not, but it is we may need to get the count of the proposals, how many proposals are there currently. Okay, so proposal count. Okay, that's it. So now let us begin creating our smart contract. Okay, so we'll just begin by creating a struct. Okay, struct. So by simply writing the keyword struct and then naming it. So what? Struct proposal. Okay, struct proposal. Yeah, looks good. So uh, struct proposal. Oh, and in this we'll define its attributes or properties. Okay, so string name, then string name of the proposal, description of the proposal, description, and then u in 256 what? Vote count. We need to keep the vote count of the proposal. Okay, makes sense. Now what we have done, we have now created this, the data structure. Okay, struct struct. Now name, description, and vote count, that's it. How will I access the proposals? Okay, so this struct in itself would be creating we would be creating the instances of this struct. Okay, this is like a blueprint. Okay, this is just like a blueprint, and we would be creating its instances, and then we need to store them somewhere. Okay, so that we may access them afterwards. So for that we are creating a what? We may create a array. Okay, so for that what we can do is proposal. So this is the data structure, data type is proposal. Okay, so this user defined struct now has become a data type. Okay, so this proposal in itself can be used as a data type. So the data type of this array would be proposal. Okay, so private and proposals. Okay, so now we have created this array. Okay, so this proposals array has now been created, and after that let us now see what is the next step. How will I access the proposals? So I will access the proposals using this array only. Okay, so I will add the proposals into this array and then access them one by one, or in whichever way I want. Okay, so now how will I access the proposal? This has been done. So keep track of voters. So the now one more mandatory requirement is to keep the track of the voters, who has voted and who has not voted. Okay, so for that we would be using a mapping. Okay, so now you may ask, what is a mapping? So a mapping, for defining a mapping, you can simply see a map here. So this is a struct. Okay, what are structs in Solidity? That's simple. I have explained it to you. Okay, so and I have even showed you how we can create a struct. Okay, so a struct is a user defined data type which allows us to create or a composite or complex data structure by combining multiple variables of different types into a single entity. See, multiple variables of different types: string name, string description, and UN256 word count. Okay, so now, what is a mapping in Solidity? In Solidity, a mapping is a data structure used to associate values with unique keys. This can be understood as a dictionary. Okay, like we have dictionaries in Python, so they store key value pairs. Okay, this mapping. Okay, it is like a dictionary on a or an associative array in other programming languages. Key points about a mapping. You can give it a read. Okay, so I have written them into the notes so that you may go through them. Okay, so these are some simple points like the structure, how is it defined. Okay, then the key value relationship, how is it a key value relationship maintained. Then the key types and the value types, storage and lookup, how the Solidity looks up into this, and how what is the benefit of using them. Okay, so it provides efficient key value lookup. Okay, so given a key, the mapping allows us to quickly retrieve the associated values. Default values. This is an important point. Okay, if the mappings are not sorry, not the mappings are they are always not iterable. Okay, so just like in dictionaries, they in Python, if you know, they are also not iterable. Like we do not know if what is the index. Okay, so we cannot access them by using their index. Say in a array, we can access the values of that array by using the indexes. Okay, so what it has stored at what index, but in a mapping there is no such thing as indexes. Okay, so mappings are not iterable. You cannot iterate, or like we cannot iterate through iterating means to accessing it. Okay, so accessing it one by one to access the mapping in one by one in a order in which it was entered. So we cannot do that here. Okay, in array we may do that, we can do that. Okay, so in an array it's very simple. You create a for loop and then access its value one by one. As in Solidity, mappings are not iterable. Okay, meaning we cannot loop through all the key value pairs directly. Additionally, mappings have a default value. For example, a mapping with a boolean value, default value is false. Okay, that's it. Understood? Now modifying the mappings. This is also simple, and mappings are commonly used in Solidity to implement various data storage and lookup patterns. Okay, so now let us see the use of them. So this is the key. Okay, address would be the key, and this is the format in which a mapping is created. Okay, this would be the this address is the data type of the key, and this boolean is the data type of the value. Okay, so public, and what we will name this. Okay, voters. So we have now named our mapping as voters. Let us get back to it. Okay, so now what we need to do, now we need to create the functions. See, keep track of voters and the functionalities: add proposal, vote on a proposal, get proposal count. These are the functionalities which we are now going to create. Okay, function, first of all, adding a proposal. Add proposal. Okay, so string memory. uh, you must remember, I have told you about the memory keyword. If you don't know, please go through my previous videos. But in short, memory is a keyword which is used to denote that we this parameter, this name. Okay, this is a temporary parameter, and we do not want that to be stored in our blockchain. Okay, we do not want that to store in the blockchain. And what gets stored on the onto the blockchain? State variables. Okay, So state variables get stored onto the blockchain, and we do not want this name to be stored on the blockchain. Okay, so for detailed, you can go through my previous videos. Okay, now other thing we need here is to add a proposal. We need its description from the user. And while creating it, okay, so we do not need a vote, okay, because while creating, always the vote count would be 0. Okay, initially no one has voted for it. So public, and now we'll okay, yeah, so I forgot adding memory keyword here, and that's it, looks good. And now we need to, so first of all, we need to create the instance, this the instance of this struct here. Okay, so we are going to do so only proposal, proposal, and to do that we follow this pattern only. Okay, so what we will be doing is we would be assigning the attributes their values. Okay, so the attributes are name, description, and vote count. Good. So the value for the this instance would be this name, this name. Okay, so we are assigning this. Then uh, description. Oh no, not this one. Description. Okay, just leave it here, and because we need this description, this one. Okay, this description here, and we want to assign the value of this description to the attribute description for the for this instance, for this current instance. Okay, and every time the user creates calls the function add proposal, he or she would be creating the new instance of this data type. Okay, this proposal struct, and assign and in that instance the values would be these values which the user will pass through by calling this function. When he will be calling this function, he will pass these values, and these values will get assigned to these attributes of this instance. Okay, I guess it makes it very clear. And now vote count, vote count. Looks good. So now we have created this instance, but what we need to do here is that we need this proposal to be this instance to be added in our array of proposals. Okay, proposals dot push, one parenthesis here and other here. I guess it makes sense. And now we'll use a semicolon to say now this instance has been created and we have added this instance into our proposals array. Okay, looks good. Now our next step is to create the other functionality, that is to allow the user to vote on it. Okay, so we'll now create a function called wait a sec, function vote. Okay, so in this function we will require only the in this array. Okay, so in this array it's stored, so it's stored in a sequential manner. Okay, so we just require from the voter the UN256 the ID of the index of the proposal. Okay, so proposal index, then it is public only, and we'll define it. Okay, so what we will be doing is proposal we would be increasing. See, we are accessing uh, this array, this proposals array, by using this proposal index, which the user will proposal index, which the user will give us, and then by using this dot, we are accessing its vote count and then increasing it. Okay, so we can increase it by plus plus. Okay, by using this we can simply increase the vote count of this vote, uh, of this proposal. Okay, so now what we'll be doing is, once the user has casted his vote, that's it. And we also need to do one thing. Once the user has voted, we need to ensure that the user's address gets stored into this mapping voters. Okay, because what we'll do is we'll make it true. Okay, this boolean value is true and the address is the key, and the value would be true, that yes, this user has now voted. Okay, so that's very simple. Voters and message dot sender. Okay, I have told you this message dot sender, what this means. Please comment down if you know. I have told you in the previous videos. I guess you all must be knowing. So if you don't know, you can watch the previous videos. And so now one thing to note here is that we have done with the basic functionality of this function. But the thing is, we need to make sure that the user is voting for the correct index only. Okay, he may not vote for a particular index which is not there in the array. Okay, it may be possible that he may say ki I am voting for the index 5, but there is no index 5. Okay, so that makes no sense. So we are keeping a required condition as that the uh, proposals proposal index which the user will give us should be less than the length of the array at that time. Okay, so, okay, dot length. Okay, and we need to give a error message also. We can say ki uh, invalid length the proposal. hmm? Makes sense. Index, because this length is genuinely invalid, and then just a semicolon. Now one more thing. Okay, so we need to make sure that the user which has voted may not vote again, you know. That is why we are making this true. But when are we checking it? Is if the user has voted or not? So we need to make a required condition. We can make a required condition that that will check if the voter has voted or not. Matlab, this voters, this array, this mapping, sorry, not array, this mapping in this message dot sender means the address should not have voter. This mapping should not contain, this is a not sign, should not contain this message dot sender. Okay, means this address should not be true, and this should not be true in this mapping. Okay, so we are checking, and if it's true, what it will show, you have already voted. So you have already voted, simple. So that makes it very clear, I guess. Now we'll move on to our other function, that is that is now to get this, get proposal count and get proposal. Okay, so to get the proposal, what we'll do is we'll just ask the user its index, and then we can give then we can show the proposal. Okay, what its contents are, and we can even create a get proposal count to just let everyone know what are, like, how many number of proposals are currently there. Get proposal count. Okay, proposal public, and this is a what, view, only view function, and this returns. Why is it view function? Please comment in the down if you know. I have told you in the previous videos, if you remember, what is a view function. So it returns only proposals dot length. What it returns is the length of this proposals array. Okay, so that makes it very simple and clear. Now we are just left with one, this get proposal function to get the proposal. Okay, function to get the proposal, and we are asking for a what, proposal index, and we'll keep this as public view, and it returns something. What it returns is, a string, hmm, and string memory. See, this get proposal should give us the value for these three. Okay, so it should return the name of the proposal, the description of the proposal, and its vote counts. Okay, so string memory and string memory again, because the name and description are string only, and then simply uint. Why we are not using, you just tell me why we are not using memory keyword here. And for these strings, I have told you, they are like the dynamically sized arrays. Okay, so these are complex data types, and for them it is mandatory. Okay, if I will not write memory here, then you will see, so it is, see, it is showing the data location must be memory or call data. Okay, so that is why it's required here. So now what we'll see is, we'll again check for the this condition. Okay, this we'll just copy paste it. This condition should a required condition. Okay, and then we'll just move on to create a proposal, memory equals to proposals, and in this now return. So now what we have done is, we have created the instance. This proposal is the data type, this data type. Okay, this data type, and memory is the keyword that we just wanted temporarily. just for the execution of this function get proposal, and the name of the variable which will store this value. Okay, this value, what is this value? This value is the proposal which is stored at the index of the proposal index which the user will give us. Okay, so the user gives us 1 2 3 etc. So it from this private array of this proposals array, so we are accessing the the proposal stored at this index. Okay, and then we are storing that value, okay, its value into this variable proposal, and now we would return it. We would return the value by we are now accessing it. Okay, so we have now created a local instance and now we are accessing its attributes. Okay, what are its attributes? That are name, proposal, proposal dot description, and then its vote count. Okay, proposal dot. So this is now complete. I guess uh, I have made it very clear. And if you guys have any doubt, you can ask me in the comment section. And now let us deploy it. Okay, let us first compile it. So it has compiled successfully. Now deploy it. See, it has been deployed, and now we can add the proposal by giving its name. Say we want to give test1, and then just testing this smart contract. Okay, so now we can click on this add proposal and this will get added. And now some other user, say this user wants to vote for this. Okay, so if he or she wants to vote for this, he will he or she will give us the index of this proposal. Okay, to so say the index we know is 0 only, because till now we have only one proposal. In we have only added one proposal, but say he gives us value 2. Or 1. He gives us he want to vote for this proposal. Now see, the error message would be returned, this message. Okay, we have got the message that the invalid length of the proposal index, invalid length of the proposal index. See, so now if he or she votes for 0, see, it the vote is now being counted and the vote has been successfully, he has voted. Okay, so now if we want to get the details, so we'll just provide the index and the details of the proposal are here. Okay, and the number of votes. Okay, so get proposal count, currently one only, and voters. So just to check if some voter has voted or not, say this voter, we are checking for this, we are copying its address and we are checking false. But if we'll check for our previous one, this one has voted, so it will show true. See, true. Simple. So this is how you can create a simple voting on a proposal smart contract. So I have two problems for you here. Okay. So in this contract is working fine, but now we have one first, the problem is the this contract is taking the same proposal multiple time. I can add a same proposal multiple time, which should not be the ideal case. Okay. If say some other user also wants to add the same proposal, I have not made any changes. See, he or she is now able to add this again, and if we'll see the proposal count, it has been increased to +1. Now it's 2. So even he can add again this same proposal, this same user can again add, and now you will see the proposal count is 3. So first of all, we don't want that. If so, this is a task for you, just like a homework or whatever you can say. And like you can just for your practice, you can try to create a condition uh, how we can tackle this. Okay, how we can solve this problem, that the same proposal should not get added multiple times. And one more thing is problem with this contract is that if say some other proposal has been created. Okay, testing 2. Okay. And now this proposal has been created and its index would be 3. And this user, our second user, okay, this user had voted for the first test one, but now this guy cannot vote for any other proposal. If say he says I now want to vote for 3, so the error message would be shown, you have already voted, that you have already voted. Yes, this is true that this guy, this person has voted, but not for this uh, particular proposal. It has voted, but for the test one proposal, not for test two. So why is it not allowing other this same say user to vote for multiple proposals? It may be the case in ideal case scenario, it should allow the user to vote for other proposals also. It may be the case that there are 5 6 proposals and he may want to vote for 2 proposals. So these two are the assignments for you all. If you can write down the whole code and comment it down, then it's very good, but at least you should just write down, try solving it, like what approach we can follow, and give the answer of how we can tackle this problem into the comment section. And that's it from my side. Thank you all. We'll meet on day 5. Bye bye.